All right, we are going to do a video here on probability trees. And I'll start with an introduction and then we'll do two separate examples. Probability trees are just incredibly useful for visualizing a complicated probability scenario and helping us calculate the probabilities of different events or different outcomes, and then checking to make sure we did all the math right. Okay, so a really visual and useful way of solving a complicated problem. When in doubt, in probability, maybe make a tree, okay? So I have some rules, and these rules will make a lot more sense once we go through this first introductory example. So draw your tree in chronological order from left to right. So if you have a sequence of things happening, like you're rolling a die, and then you're going to draw a card, and then you're spinning a spinner, have that sort of represented left to right. First you'll have the die, and then the card, and then the spinner as you go left to right. So that's this first one, chronological order. Each split must create branches that add to 1. Okay, and I'll do a little preview down here. I'm not going to tell you what this example is of yet, but for example, this split right here created 2 branches that add up to 1. So every time you see a split, you need to make sure the branches that branch off of that split add to 1. Be like Mario. Okay, so I'm not a big video gamer, but I've heard of this game called Mario, where there's a plumber that runs through a sequence of levels and collects gold coins, I think. Okay, so when I say be like Mario, I want Mario to track every possible path down this tree, and whenever he sees a number, he's going to collect those just like he collects gold coins, and he's going to multiply them together. Okay, so for this first path, his number is going to be 0.2 times 0.5, which is a 0.1 out here. Okay, for this second path, a 0.2 times a 0.5 also gives you a 0.1 right here. Okay, so Mario is gonna follow every single possible path, pick up probabilities like they're gold coins, and then multiply them together once he gets to the end. All right. So that's what I said right here. Multiply probabilities along each path to get the leaves. So I call these, let me highlight them in green, I call these the leaves, okay? Just for no other reason other than we're making a tree and we have some branches in brown. These are all our branches, okay? And we end up with some leaves in green, okay? So multiply probabilities along each path to get the leaves. All leaves at the end have to sum to 1. So all of these numbers right here have to add up to a whole. They have to add up to 1, okay? So at the end of this, I'll do an addition problem and make sure we get 100% down there. And then lastly, in some more complicated situations, it won't happen in this first example, but it's okay to draw a branch with a probability of 0. Sometimes that helps you just visualize what's going on and helps you make sure you have a complete tree. So let's finish up this tree right here, and I'll just go track by track here, or leaf by leaf. So we have a 0.8 times a 0.3 times a 0.1. And that's a 0.024. And then we have, let's see, a 0.8 times a 0.3 times a 0.5. That's a 0.12. This will be a 0.096. See that 0 right there? Okay, means it can't happen, right? 0.8 times 0.7 times 0 is just 0. I had forgotten that we had a 0 branch on this branch. And then 0.8 times 0.7 times 1 is just 0.8 times 0.7, which is 0.56. So let's add all those up, even though if we're pretty confident that we did it correctly. Yep, and it checks out. It adds up to a 1.0. Okay, so that means we probably did it correctly. So that's a great way of checking. So let's actually do a couple real-world examples right now. And here's one involving, actually they'll both involve sports, but this first one involves volleyball and basketball. Alana's going to play one volleyball match and then one basketball game. The probability she wins the basketball game is 0.9, and the chance she wins the volleyball match is 0.4. So we want to know what's the chance she gets at least one win. So she's playing volleyball first, so let's get that set up. And let's have this be a win and this be a loss. And I always, I label a start here. Okay, it's almost like we're starting Mario off, I guess. So chance she wins volleyball is 0.4. So that means this has to be 0.6. And then she goes ahead and does her basketball game. And she has we need to draw 4 branches now. So this could be win, loss, win, loss. So the chance she wins the basketball game is 0.9. And again, 0.9 and 0.1 right there. So we have 4 leaves right there. And we'll check to make sure they add up to 1. What's the chance she gets at least one win? I'm going to highlight those in yellow. Here she has a double win, so that counts. Here she has a win and a loss. And here she has a loss and a win. So that's what our answer is going to be. We're going to add those guys up right there. Okay, so let's do our multiplication. We're doing our Mario thing now, right? 0.36 is 0.4 times 0.9, 0.04. 0.6 times 0.9 is 0.54, and 0.6 times 0.1 is 0.06. Let's add those up real quick. 0.36 plus 0.04 plus 0.54 plus 0.06. Yep, it adds up to 1.0. So that's just our check right there. And then we're going to add these 3 yellow guys together. 0.36 plus 0.04 plus 0.54. So that's a 0.94 or 94% chance she gets at least one win right there. So pretty likely. Okay. Next one, we're going to do a basketball scenario, and I call this an unbalanced tree because sometimes some branches end earlier than others. And did I say basketball? I mean baseball. So this is a baseball scenario. In basketball and baseball tournaments or series, like the World Series or the NBA Finals or something, it's usually a best of 7. So whoever wins 4 games out of the 7 possible games to be played will be the champion. But if that team wins the first 4 games, you're not going to play the next 3 games, right? So sometimes some branches end early. So I'm not going to do a best of 7 example here. That would be pretty tedious, but we're looking at a hypothetical 3-game series between the Rockies and the Dodgers. The teams are not quite evenly matched. The Dodgers have a 0.55 chance of winning each particular game. They're a little bit better of a team. First team to 2 games wins. Okay, so we're assuming if a team wins the first 2 games, they'll stop and not play the 3rd game. So what's the chance that the Rockies win the series? Okay, so we're going to go left or right. And what I'm going to do here is rather than write win or loss, I'm going to write R or D for the Rockies winning or the Dodgers winning. Okay, so here we have our first game. Here's the Rockies win, here the Dodgers win. Then we have our second game. Here the Rockies win and the Dodgers win. And here the Rockies win and the Dodgers win. But check this out. If the Rockies win the first 2 games, we're done. We don't have to do another branch right there. And same for if the Dodgers win, we're done. We can stop, okay? So we're not going to keep going with that branch because that game actually won't be played. But if it's Rockies and Dodgers, they do have to play the tiebreaker. So this will be Rockies, this will be Dodgers. And if it's Dodgers and Rockies, they will also play a tiebreaker. So this could be Rockies and this could be Dodgers. And I encourage you to try to keep things organized. You can see I always have the Rockies as sort of the top branch, the Dodgers is the bottom branch. You just make sure you're getting every single possibility. So we actually have 6 leaves here, 1 up top, 1 right there, there, and then the bottom one. Okay, so what's the chance the Rockies win the series? So what's the chance the Rockies have 2 wins? So that's going to be this one. And that would be this one. That would be Rockies, Dodgers, Rockies. and it would be this one as well. So those are the three probabilities we're going to add up to find the chance the Rockies win. By the way, right now it might be a good time to make an intuitive guess and see what you guess. It should be less than 50%, I would think, right? Since the Dodgers are a better team on an individual game basis. Let's throw some numbers in. So Rockies have a 0.45 chance of winning. So every D is a 0.55 and every R is a 0.45. So we can throw all those numbers in. Every R is a 0.45, every D is a 0.55. Okay, so let's go ahead and do them here. So lots of multiplication we're going to be doing right now. And I'm going to write out all my decimal places just for now. I might end up rounding down the road. Let's see, 0.55 squared times 0.45. A lot of this is just really making sure you're staying organized. Is probably the biggest suggestion here. You can be a little bit clever here, so look at this one I'm about to do. That has 2 Rockies wins and 1 Dodger win, and we had that up here already, so that should be the same. Those wins and losses just happen in a different order, but that's not going to change. And then same here, 2 Dodgers wins and 1 Rocky win is going to be a 0.1366125, and then 2 straight Dodgers wins is 0.3025. So 2 Dodgers wins is the most likely of all the outcomes, although it's more likely that something else overall would happen because it's 30% chance. It's less than half and half. So let's add up what we need to. And I get a 0.42525, so about 43%. One reason I like this problem is I think it's a little bit counterintuitive. In every individual game, the Rockies have a 45% chance of winning, but they only have a 43% chance of winning the series overall. And that's one of the things about baseball. You need a lot of games to really highlight who the better team is. All right, so 43% chance the Rockies win that series. That's a good place to stop right there.